What do you want to eat tonight? It's a question that harkens back to the very beginnings of human civilization. As societies developed and agriculture replaced hunting and gathering, the process of producing food kept pace with the growth in population. However, since the Industrial Revolution, business and industry now do the cooking that was once the domain of the home kitchen. Sugarcane was introduced to Florida in 1512 by the Spanish explorer Ponce de Leon. Today, about 1/4 of the nation's sugar is produced here. Intensive agricultural production in this environmentally sensitive region requires careful waste management.
The Everglades are a unique subtropical ecosystem located in the southern part of the state of Florida. Originally they were about 10,000 square kilometers or about 400 square miles. Today they're about half that size. The reason they're half that size is that a number of canals have been dug, the water levels have been changed, and that's brought about the change of the land to urban areas and to agricultural areas, and has basically led to some of the problems, the environmental problems that we face today.
One of the main issues threatening the Everglades is the amount of phosphate present in the agricultural and urban runoff. Phosphate, a substance found in fertilizers and detergents, serves as a nutrient to what has historically been a nutrient-starved environment. To maintain a healthy ecosystem, the phosphate levels can be no more than 10 parts per billion. Urban and agricultural runoff have raised these levels to over 100 parts per billion, requiring process modifications.
We have changed our pumping procedures. We don't pump as often. We don't pump as fast. And if we have a lot of water, then we'll store it on site and release it slowly, and we wait for the water to still, because a lot of phosphorus and other nutrients are tied up in the soil because it's a natural component of the soil. And when you still the water, those things settle out as sediment. It takes a lot of phosphorus out immediately.
The agricultural use of fertilizers are not the only threat to local ecosystems. The use of pesticides also poses a danger.
With the disappointing realization that pesticides were no panacea for pest control, researchers went to work to find alternative tactics that could be used. They came up with such tactics as plant resistance, biological control using parasites, predators, and pathogens.
The sugarcane borer is a pest that can destroy an entire sugar crop. This menace is being eradicated through biological controls, one of which is the introduction of a natural predator, the Cotesia.
Cotesia is actually a tiny wasp that's no bigger than a dog gnat, and it's kind of amazing. It flies around in sugarcane and finds these little sugarcane borer caterpillars. It'll hop right on their back, and its stinger has been modified into a little egg-laying tube. So once the little parasite, the good guy, pumps the eggs into the caterpillar, the little adult parasite goes away, but these eggs remain inside the caterpillar. After several days to a week, the caterpillar doesn't feel too well because you see these little eggs have hatched and the little baby parasites are growing inside of it. Then after about 10 days, it's Innsville for the caterpillar, because he croaks and these little parasites emerge right out of the cadaver. They pupate like all good complete metamorphosis insects do, and then the adult parasites emerge and go out looking for more of the bad guy caterpillars.
In order to produce Cotesia, the integrated pest management team must also grow the sugarcane borer that serves as the Cotesia's host.
The way we release those parasites is interesting. We take the pupal stage of the Cotesia. It's a little white cottony mass of 40 or 50 pupae, and we put those in a biodegradable paper container and basically just throw them out into the cane field where the borers are a problem. The Cotesia will emerge inside the little paper containers, mate, and then disperse out of them in search of caterpillars that they can parasitize.
Following a successful growing season, mechanical harvesters cut the mature cane stalks and load them into rail cars to be transported to the mill for processing. During the harvest period, hundreds of carloads are unloaded at the mill every day. High-pressure rollers crush the cane and extract over half of the juice from the fibrous stalk. Up to 4,000 gallons of sugar juice per minute can be extracted during the crushing process. The residual fiber, called bagasse, is moved by conveyors and later used as an energy source for the mill's cogeneration unit. Its stack emissions are controlled by an electrostatic precipitator. Inside the mill, through clarification, evaporation, and crystallization, golden sugar crystals are produced. A byproduct of raw sugar processing, molasses, nearly 30 million gallons per year, is sold as a cattle food supplement. The raw sugar is transported to refineries where it is processed into the familiar white sugar sold in stores. The ongoing maintenance of equipment and machines essential to the sugar-making process can generate waste streams that require treatment. Some petroleum-based solvents have the ability to leach hazardous metals like chrome or lead out of equipment parts. Every batch of spent solvent is tested. If hazardous, it is appropriately disposed of. If not, the solvent is distilled and recycled. This reduces hazardous solvent waste by thousands of pounds per year. Over half the small equipment parts are now cleaned using water and a detergent. It is especially desirable due to its non-hazardous characteristics and alkaline pH, which prevents metals from leaching. Within 6 months of the aqueous washer's use at one shop, hazardous waste was reduced by 14%. When U.S. sugar engineers designed and built a washer that cleaned heavy, large parts without using a solvent at all, the results were impressive.
We go through a pressure wash with steam and hot water rather than another kind of a solvent, because hot water and water under pressure will clean. And then that water is constantly recycled through carbon filters, charbone, and some other kinds of ion exchange resins, and regenerated. We go through a whole repair season using just that one parts washer, and we'll clean it out. And what we find is that the material left over, the large pieces of grease and oils that have conglomerated, are characteristically solid waste. They meet the used oil criteria. We are able to burn them in our boiler for energy recovery.
Wastewater streams from sugar processing are forced through a solids skimmer, where the thick organics are collected for reuse as an energy source. The water then travels to the dissolved air flotation unit, where oil sheens and droplets are collected for removal.
The main tank shoots air through jets into the bottom of the tank, and it creates bubbles. Right? And as the bubbles rise, they pick the oil up, and the oil coats the outside of that bubble. When it gets to the top, it comes in contact with the flocculants, forms a solid. That solid is skimmed off in a clarifier type operation. The clean water cascades out of the inner chamber of the DAF, which has a cylinder within a cylinder, and then it goes out essentially clean as it comes in.
Wastewater streams leaving the mill are stored in evaporation ponds where most of the solids settle out. The clarified water is then pumped into narrow canals called finger ponds. The higher water level in the canal slowly percolates through the soil and into the ponds. The soil acts as a natural attenuation system and further filters out impurities.
We have a rookery out there at this time for giant egrets, ebony ibis, white ibis, herons, cattle egrets, and they're all living together in stilts. And these areas are clean enough to support them. So, that's a good practical demonstration of how clean our water really is.
Through various initiatives and source reduction programs, U.S. Sugar has taken proactive measures to ensure environmental sustainability. Another major crop in South Florida is citrus. At one of the largest citrus processing plants in the United States, many practices are utilized to assure both a high-quality juice and a safe environment.
The process of extracting the juice out of oranges really begins in the grove. Here at Southern Gardens we have about 30,000 acres of our own groves. Harvesters bring the oranges in some 150 to 175 truckloads every day here into our fruit yard. Then on a first-come, first-served basis, those oranges are brought over to our unloading truck ramps.
The oranges are washed, graded, and rolled onto a conveyor where they're sized. Each juice extractor can squeeze 500 oranges a minute. As the juice is extracted, the peel is separated from the soft white rag material and seeds. The juice is forced into a strainer tube before being sent to the chilled storage tanks, which can hold 16 million gallons of pure orange juice.
The orange is made up of 4 pieces. As you see on the outside, it's made of the peel. On the inside, you've got juice. In the middle of the orange, you have a core material, which consists of seeds and rag. And then you have, on the inside the peel, you have oil. So these 4 different pieces go to different processes within the plant. The juice goes for further processing to either make a premium juice, which is called NFC, or it's turned into concentrate. The peel, or the outside of the orange, goes to the feed mill and is turned to cattle feed, as well as the middle of the orange, which is both seeds and rag.
Another byproduct from the orange is the oil from its peel. These oils are used as fragrances or essences, as well as a product called dolimonene, which is used as an adhesive or solvent for chemical products. The recovery of the oil starts in the juice extraction process. As the orange is pressed, a water spray covers the orange peel. Oil droplets form and are captured by the oil recovery pipeline. That oil then passes through a finisher which removes any large peel particles. The oil emulsion is further refined through 2 centrifuging processes. The finished product is then sent to a large tank for storage. Once the oil has been extracted, the peel, rag, and seeds are turned into feed pellets for cattle. Lime is used to start the decomposition process. It is fed into a reaction screw where the water, peel, and core material are mixed together. A press removes the water and leaves a cake. The water passes into a waste heat evaporator where the water as well as dolimonene and molasses are removed. The pressed cake of peel, rag, and seeds then travel through a rotary dryer, is shaped into pellets, and sent to the warehouse.
The feed mill basically takes several of our waste streams from our processing plant and turns them into cattle feed such as this. This cattle feed is shipped all over the world and is used as a replacement as corn within the feed.
There are 2 important water streams utilized at Southern Gardens Citrus. The first, called taste condensate, is water recovered from the evaporating and concentrating of juice from the orange. This clean water source is used to sanitize lines for juice processing and to irrigate the groves. The second source of water is local groundwater, which is used for washing incoming oranges and areas where the facility gets leaves, branches, and dirt. This stream proceeds to the feed mill before entering the wastewater treatment process. In the oxidation ditches, nutrients such as nitrogen and phosphate are added to the wastewater.
We have what's called a complete mix aeration system. Complete mix because we use a set of 3 ditches where we have rotor aerators in there which are continually mixing the water within the ditches. The aerators serve 2 purposes. One is to completely mix the water in the ditches, and 2 is to increase the dissolved oxygen within the ditches.
Once clarifiers remove the solids, the clear water goes over the top into a weir, and from there into the pond, which is also used to irrigate the groves, saving limited groundwater supply. The activated sludge from the bottom of the clarifiers is returned to the ditches to help bacteria grow or sent to the feed mill.
Inside the ditches, we take dissolved oxygen tests on a daily basis to ensure that the oxygen is at the appropriate levels for bacteria growth. We also take pH levels because the type of bacteria that we're looking to grow grows best between pHs of 5.5 and 7.0.
Even though sugarcane and citrus are known as environmentally friendly crops, they are still subject to regulations. At the South Florida Water Management District, a state-run government agency, engineers and scientists try to balance the needs of development, agriculture, and urban areas with water supply, flood control, and environmental conservation.
From a biodiversity standpoint, the Everglades are just one of the most unique and fabulous wetlands in the whole world. From the human standpoint, of course, the Everglades are responsible for the water supply for most of South Florida.
One way the South Florida Water Management District has been able to detect the presence of excessive agricultural nutrients, such as phosphate, is the emergence of tall plants called cattails. Runoff from the agricultural areas has enriched the soils to such an extent that cattails have outcompeted the sawgrass and other native species.
When you change the system away from what it was, then you've basically lost the beginning of that food web that's so important for supporting the biological components of the system that we find desirable.
To counteract this imbalance, the district has designed and built a 4,000-acre man-made marsh known as the Everglades Nutrient Removal Project. Through engineered biological and chemical processes that mimic natural systems, 80% of the phosphate is captured by the plants. A mass balance is used to monitor the phosphate levels within the system. Rainfall is also monitored for phosphate content. Devices measure the exchange between the surface water and the groundwater in order to account for any lost phosphate.
When the state of Florida enacted its Water Resources Act, it required all development that changes property from something that was native to something more intensive. The requirement was for each one of these properties to develop and set aside a certain amount of properties for retention or detention. That's taken a lot of property, sometimes 15 to 20, 25% of the property, which would normally be in production and be making money, is now has to be set aside for cleaning water.
Nestled between the mountains and the Oregon coast are the lush, grassy valleys that support an abundance of dairy farms. In Tillamook County, cheese manufacturing is not only contributing to the economic base of the region, but to local environmental concerns.
The process of making cheese here at Tillamook really starts on the farm with the high-quality milk. That is really the foundation for the Tillamook quality. From that point on, we bring the milk into the plant. We add a starter to it, which is culture, includes lactic bacteria. Those bacteria then work in our vats for a period of about an hour. From that point then the curd has separated from the whey, or the watery part of the milk, and we process that cheese through our cheddaring machine by turning it, keeping it warm, and slowly working it until it gets into a solid mat. Then we cut that into roughly finger-sized pieces, salt it to the appropriate flavor level, and then pack it into 40-pound containers that will be used then for aging.
In the manufacture of dairy products, you create a couple different waste streams. One is whey. About 90% of the milk that comes into the plant goes out as whey. You have that, and you also have wastewater that's generated through product loss and also in the cleanup process.
Each day, the wastewater treatment plant receives about 250,000 gallons of raw influent, which must be treated before being discharged. After the raw influent leaves the primary clarifier, it is sent to a surge tank to buffer its pH. The now buffered raw influent is sent to a first-stage aeration basin where it is mixed with bacteria and aerated for 3 days. During this time period, the bacteria feeds on the biological oxygen demand, or BOD, creating carbon dioxide, water, and more bacteria. Clarifiers remove about 90% of the BOD before the clear liquid is sent to a second-stage aeration basin, in which much of the remaining BOD is removed. After a day, the wastewater goes to the final clarifier, where the solids are separated and the finished effluent is chlorinated, dechlorinated, and released into the environment. During the cheese-making process, whey is drained off the curds and pumped into a separation unit. The whey is then dried into a powder and packaged as a food supplement for candy bars, ice cream, and baby food. Another major component of Tillamook's waste treatment protocol is the way in which the company handles its biosolids. With the addition of a flocculant and coagulant, solids that remain from the aerobic digester are dewatered on a belt press. The result is a cake, usually about 12% solids. Lime is added to kill any pathogens or bacteria. It is then transported to the field and applied as a soil amendment to grow grass for the nearly 25,000 cows which provide milk for Tillamook cheese.
Environmental management for the dairy industry has changed dramatically in the last 10 years. It's changed from a reactionary program to a proactive program where the creamery actively tries to reduce, reuse, and recycle different waste streams, minimize the impact upon the environment in all areas.
So we have about 208 million tons of trash disposed every year, or created every year by Americans. And about a third of that is packaging. A big part of that is food packaging. All of those activities have an environmental impact. We don't necessarily see them, but that's really the big impact of our consumer culture.
As Americans become more conscious of the negative impacts of a throwaway society, the fast food or quick-serve industry was facing a public outcry regarding their packaging practices.
Solid waste issues were really becoming a prominent concern to a lot of Americans, and McDonald's and its polystyrene foam clamshell really became the target of that concern.
To better understand the exact sources of McDonald's waste generation, EDF staff members took jobs at the restaurants.
I went to the Upper West Side of Manhattan and made Egg McMuffins and Big Macs and mopped the floor and did some dishes. We learned a lot of things working in McDonald's restaurants and being in the restaurants a lot. One major thing is most of the waste or the trash created at the restaurant actually occurs behind the counter, about 2/3 of the material. Items like corrugated boxes, which can easily be recycled, eggshells and coffee grinds, which can be composted, certain kinds of plastic, which can also be collected and recycled.
Another major area where McDonald's is trying to help the environment is in source reduction. Some examples include dispensing ketchup and mustard in bulk rather than individual packets. Alternative methods of folding napkins reduce paper content by 21% while retaining the same size. However, McDonald's most visible source reduction effort was switching from the polystyrene foam clamshell packaging to a thinner, lighter paper wrap, or in some cases, a very lightweight paper box. This reduced the weight and the size of that packaging and used less raw materials and energy in its manufacturing. McDonald's is now adding recycled content, not only in its food packaging, but in other items as well.
So here's the McDonald's paper bag. This is the bag they're using in 1997. If you'd gone to McDonald's 10 years ago, you would have received a bright white 100% virgin paper bag. The job the bag does is to get the meal from the front counter to the front seat of your car or wherever you're taking it. And what we realized is the takeout bag doesn't have to be bright white. You don't need to cut down trees to do that job. McDonald's, working with us, selected a brown paper bag that was 100% recycled. And their initial concern was that customers might see this as cheap or dirty, something you buy hardware or nails in. But McDonald's sort of solved that problem by putting the recycled logo, the arrows on the bag, and customers saw it and loved it, and McDonald's switched over very rapidly.
Farmers really are the first stewards. They've known for a long time that that's where their bread is buttered. And if they take good care of their fields, they'll be better off. That's why we look at what's the nutrient value in the ashes, what's the nutrient value in the biogas, what's the nutrient value in the muds that come through, and let's put them back out there and build those fields back again.
In the citrus industry itself, from an environmental standpoint, we're very, I guess, proactive in controlling any of our waste coming off. We're looking at making sure that there's no waste coming from our plants, and whatever waste that are, we're using them in any proactive way we can, such as spraying our own groves or using them to fertilize other areas.
McDonald's is really, if you think about it, a local enterprise. There's people from a local community working and dealing with individuals who come in, and that's how they sort of perceive themselves from the standpoint of the environment.
Advances in science and technology have led humans into the far reaches of space, but not diminished the simple need to feed ourselves. Continuous development of agricultural management practices and pollution prevention for the food industries are vital. Only then can we be assured of our ability to feed the Earth's ever-growing population.